Hi, it's Jakub again, and I will show you now how to solve the last third example from today's problem set, the Pigeonhole principle. There are 6 people playing a game online together. Among any 3 people, at least 2 people know each other. Show that there is a group of 3 people that all know each other, right? So what that means is that if you pick any 3 of those people, right, then we know that some 2 of them know each other, right? But we don't know who that is, basically. So let's start and pick one person. Pick one person, let's call them Ashley. This is Ashley here, right? And Ashley knows some people, right? Out of the 5 remaining people, there are either 3 Ashley knows or 3 Ashley does not know, okay? So what I'm saying basically is that there are 2 possibilities. Either there are at least 3 people that Ashley knows, or at least 3 people that Ashley does not know, okay? And actually the pigeonhole principle guarantees that, but if you don't believe me, you can go through all the cases, right? Because Ashley can know 5, 4, 3, 2, 1, or 0 people from the remaining 5, okay? If he knows 5 people, there are at least 3 he knows. The same goes if he knows exactly 4 or exactly 3 people, right? But if he knows exactly 2 people, he does not know the other 3, right? So there are at least 3 people he does not know. The same happens if he knows exactly 1 person or if he doesn't know anybody. I guess Ashley can be a girl as well. So yes, let's for now assume that there are 3 people that Ashley knows, okay? Let's mark them with those arrows. Those are the people that Ashley knows. He might know the other 2 as well, right? But we are just ignoring them. It is possible for Ashley to know everybody, but we are saying, let's say at least 3 people that he knows. So we don't want to think about all 6 cases. We only want to consider 2 cases. It is much faster that way. But it is possible for Ashley to know everybody. Right, it is possible. Okay, so we pick those 3 people. Ashley knows those 3 people. What happens next? Among those 3 people, like, so if we now pick the group of 3, we know that among any 3 people, there are 2 that know each other, right? And currently we don't have any arrows drawn between those 3 people that correspond to knowing each other, right? But we know there must be one arrow. So let's draw this arrow here. And we now see that if we say that those 2 people know each other, there is an arrow here, then now we have a triangle, right? And this triangle means that there are 3 people who all know each other, right? So we have found 3 people, 2 of the people that Ashley knows, and Ashley himself, right? So this is 1, 2, and 3. Those 3 people all know each other. So in this case, this is true, right? What if there are 3 people who Ashley doesn't know, right? So again, Ashley might not know anybody. Ashley might know 1 person, or Ashley might know 2 people, right? In all those 3 cases, there are some 3 people that he doesn't know. And I mark them with the blue. These are the 3 people, right? Among every 3 people, there are 2 who know each other. So picking 2 of those and Ashley, the 2 know each other. How does it work? If I pick those 3, right, I know there must be one arrow somewhere here, right? And it can't be an arrow between any of those and Ashley because we know that Ashley doesn't know any of those people. So it must be this arrow here, right? Then I do the same thing. I pick those 3 people and I say the same thing. There cannot be an arrow between this person and Ashley because Ashley doesn't know this person. Same here. So there must be an arrow here, right? I actually drew nicer arrows. The same goes if I pick those three people, this one, and Ashley, right? In either way, we actually do have a triple, three people that all know each other. This is the first person, this is the second person, this is the third person. We have created this triangle, but it doesn't involve Ashley this time, because Ashley doesn't know enough people, right? So sad times for Ashley. We have found the triangle, found the three people that all know each other, you just know Ashley. It means all three people know each other, all those three, right? So in either case, if Ashley knows more than three people or less than three people, there are some three people that all know each other. It just might involve Ashley or not. So if we look on both cases, and we found out in each case it is true that there are three people that know each other. It just differs if Ashley is among them or not, right? So we've considered all the cases, and we've concluded that this is correct, okay? Right, so that will be it for this problem. Thank you very much.